Hello students, welcome to this lecture in which we're going to try to talk about binary code that can detect more than one errors. Not precisely, but some techniques to deal with it, because if our previous code would struggle with when there are more than one errors happen during the transmission. So this method is nearest neighbor method. We've already seen nearest neighbor method when we talked about graph theory. So to implement this method, we need, and this method will be for the binary codes. This method will be for the binary codes. So to implement this method, we need to go a little bit aside and step aside and learn some definitions. First definition that we're going to use is, but it's a simple definition. It's what string is. And string is a collection of zeros and ones, So basically binary strings, that's how they called, because they have either zeros or ones. And second thing is that what is the distance between two strings? The distance between two strings of equal lengths. So the length has to be the same. So what is the distance between two strings of equal lengths? We will state the following: is the number of positions in which the strings differ. And at first, it's not really clear what it means. It is not really clear, but let's look at the example to understand what's going on. And you will see this is relatively easy. So let's look at the example. First example we're gonna do, we have two strings. String U is 1110010, and string V is 11111010. All right, the assignment wants us to find the distance between U and V. So how do you do that? You need to find the number of places in which these two strings are different. So what you're gonna do, you're gonna write U 1110010, and since V has exactly the same length, you can write the items from V directly underneath the items from U. So you can write 111010. And then what you can do, you can go and check where they're the same and where they're different. The same, different. So we'll cross it out. The same. So there is only one position in which they're different. So the distance is equal to 1. And that was the first exercise. Let's look at the second exercise when the P is 10010000 and Q is 1110000. So again, find the distance between P and Q. Find the distance between P and Q. So again, we're going to write P 1001000, and we're going to write Q, which is 111 0, 0, 0, 0. And then we're going to see where the same and where the different. There's the same, different, 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 same, same, same. So in 3 places, we have a difference, 1, 2, 3. So we say the distance is equal to 3. Again, relatively simple idea. So now we learned how to calculate the distance. We can create a scheme which will be the nearest neighbor. So nearest neighbor scheme. And again, this is a different nearest neighbor that is for the binary code. So let's go through the scheme. Again, scheme has to have steps. So step number 1 says that we can make a list of all legal words. We can make a list of all legal words. So small example, the one that we had before, it doesn't have to be, it could be more spaces. So example would be, we have four places, and for these 4 places, we have 2 to the 4, which is 16 different legal words or messages. So why 2 to the 4? Because fundamental principle of counting. We have a choice of 0 or 1 for each one of them. So there are exactly 2 choices for each one. And according to the fundamental principle of counting, we multiply 2 by 2 by 2 by 2, which is 2 to the 4, which is 16 different legal words. But when we have a legal words, we have a scheme how to create code words, right? So on the step number 2, we can proceed and create a list. We can think of it as vocabulary of all legal code words. So we'll create, for our example, add 3 check digits to each of the words from step 1. Words from step 1 to get 16 legal code words. That's for our specific example. Again, examples could be a little different, but for our example, that's what it would be. So step number 3, when we receive a word, when we get a word from the transmission, when we get a word from the transmission, we compare it to the list of words from step 2, to the list of words from step 2. And there are a couple of things could happen. Could happen if it is one of the legal code words, if it is one of the legal code words, then we are done. So basically we assume that there are no errors. We assume that there are no errors. And we retrieve the message word. And maybe we'll write it as a sentence. We assume that there are no errors, and we retrieve the message word. And in our example, we take the first 4 bits. Right? That was step number 3. And step number 4. Suppose code word is not in the list. Suppose code word is not in the list. Of all legal code words from step 2. Then it is not a legal code word. So that means there is an error. And there is an error. So what we're going to do, how do we find where the error happened? To find where the error happened, we have to go through, we have to take all of the words. So we're going to go through the list of all legal code words from step 2. And choose the one that differs the list from the code word in question. Right, and that's the idea of the nearest neighbor. So what does it mean, differs the list? That means has the shortest distance, right? Has the shortest distance from the code word in question. And that's it. That's the whole idea of this algorithm. And there will be a few homework questions to practice, or we can discuss it in class if it's not clear. But that's the algorithm which is called nearest neighbor algorithm. And that's probably a good place to stop this lecture, and we'll move on in the next one.